Hello student, welcome to our fourth lesson. In this lesson, we are going to discuss the pressure law. Now, the pressure law relates the pressure of a fixed mass of a gas to its absolute temperature, but in here now the volume is kept constant. Now, to investigate the relationship between the pressure and the temperature of a fixed mass of a gas at a constant volume, we use the following apparatus. We have the thermometer. As you can see, we have the round bottomed flask, we have the pressure gauge, and we have now the container is fixed, or we have now sealed the container to ensure that this volume is constant. Remember, we must ensure that the volume is constant. Now, what we are changing now is the pressure and the temperature. Now, we proceed as follows. Set up the apparatus as shown. Then number 2, record the initial temperature and pressure reading. That is the initial. Then heat the water bath gently and obtain at least 8 readings at suitable temperature intervals. So we are now heating this water bath so that now we can increase the temperature. And from there, we are supposed to see the pressure. But the volume is kept constant. Now, record the results in the following table. We have the temperature, we have the pressure, and then we have the pressure over the temperature. You're supposed to get the readings there. Now, the air in the tube connecting the gauge to the flask may be at lower temperature than the air in the flask. Remember, we have the air that is connecting in here. So we are saying that it might be at the lower temperature than the temperature that is here. Now, therefore, the tube must be as short as possible. This part must be as short as possible to ensure that now the temperature, we are talking of this tube that is connecting the gauge to the flask, this part, it should be as short as possible to ensure that there is no that big difference between the temperatures. Now from there, after doing all that, you have now the results in your table. You're supposed to have the following observation. It is observed that increase in temperature causes an increase in pressure. And when you plot a graph of pressure against temperature, it gives again a straight line. As you can see, we have the pressure and the temperature. So as you increase the temperature, the pressure also increases. But it is starting at a given point because, again, the temperature, we are not starting when the temperature is 0. But when you extrapolate again, you find that the graph or the line will cut the temperature axis at negative 273 degrees Celsius. Now, when the graph is extrapolated, it cuts the temperature axis at negative 273 degrees Celsius, and that is what we call the absolute 0. Therefore, the graph below shows the same graph on the absolute temperature scale. So when you plot now against pressure against the temperature, but now you use the absolute scale, you find that it is a straight line through the origin. Remember, at absolute scale, we start at 0 Kelvin, which is equivalent to negative 273 degrees Celsius. Then from there, we have the pressure law. And we have seen that from our illustration, we are keeping the volume constant. But now the pressure and the temperature, we have seen that they are directly proportional. Therefore, we can state the law as the pressure of a fixed mass of a gas is directly proportional to absolute temperature at constant volume. So mathematically, we have that the pressure is directly proportional to temperature at constant temperature. Not at constant volume, that it should be volume. Now, when you replace the sign of proportionality with an equal sign and a constant, you get that P is equals to KT. And now when you divide through by T, you get that P over T is equals to constant. And this is at constant volume. Therefore, P1 over T1 is equals to P2 over T2. Where this one, P1 and T1, they are initial values of temperature and pressure. And P2 and T2 are the final values of temperature and pressure. Now we move to an example. We have a car tire is at an air pressure of 4.0 times 10 to the power 5 pascals, at a temperature of 27 degrees Celsius. Now, while it is running, the temperature rises to 75 degrees Celsius. What is the new pressure in the tire? So we proceed as follows. We are given the value of P1, 4.0 times 10 to the power 5 pascals. We are given T1, which is 27 degrees Celsius. You have to convert that into Kelvin. Remember, all the working should be, the temperature should be in Kelvin scale. So this one is 27 plus 273, you get 300 Kelvin. Then T2 is 75 plus 273, you get 348 Kelvin. Now we are getting the, we are trying to get the value of P2. So we proceed as follows. We have seen that P1 over T1 is equals to P2 over T2. So when you substitute the values, and this is 4.0 times 10 to the power 5. Remember, we are getting this. Divided by 300. Then to get P2, you multiply through by 348. And by so doing, you find that your P2 is 4.64 times 10 to the power 5 pascals. Then after that, we have the second example. A gas in container has a pressure of 3.0 times 10 to the power 5 pascals when the temperature is 20 degrees Celsius. Determine the pressure of the gas when the temperature is lowered to -5 degrees Celsius. And now here we are assuming that the volume is constant. So we proceed as follows. We are given the value T1 as 20. That is equivalent to 293. Remember, you're just adding 273. Then T2 is -5 degrees. Again, when you add 273, you get 268 Kelvin. You have P1 that is given 3.0 times 10 to the power 5. And then now we are looking for P2. Again, we start by writing the formula. And then after writing the formula, substitute the values. To get P2, you need just to multiply through by 268 Kelvin. And by so doing, you find that your P2 is 2.744 times 10 to the power 5 pascals. Then example 3. At the start of the journey, the temperature and the pressure of inside a car tire was 17 degrees and 300 pascals. Calculate the temperature during the journey. So we have T1, 17 plus 273, you get 290. Then P1, 300 pascals. Then T2 is what we are looking for. And P2. Remember, we are not given even the final temperature. But now we are supposed to calculate the temperature during the journey. So we start by writing the formula. P1 over T1 is equals to P2 over T2. So substituting the values, this will be 300 pascals divided by 290 Kelvin. Now our T2 now will be in terms of P2. So which is P2 times 290 over 300. When you divide this, you get that it will be 0.97 P2 Kelvin. That will be our final temperature. Then from there we have the assignment. Again, if you look at the assignment, it is testing what we have just learned. So make sure that you practice a lot, you discuss with your peers, and then come and attempt the assignment. So thank you, and let us meet in our next lesson.